Good afternoon, everyone. My name is Vishnu Singh. I am working as a lecturer in IIMT College of Polytechnic, Greater Noida. So, topic that we will be discussing today is what are the coordinate systems that are used in a CNC machine, and what are the control systems that we generally follow in a CNC machines. So, let's move forward. So, we have in the previous slide we have already discussed what are the components of NC system were and what was the procedure that was followed in an NC machine. So let's start our today's topic. What are the coordinate systems that are used in an NC machine? So basically in an NC machine, there are two types of coordinate system that we use. One is for flat and prismatic work parts. By flat and prismatic work parts means if a workpiece is in a rectangular or square shape, then those workpiece come in the category of flat work parts. And another is for rotational work parts. As in the case of a lathe machine, we use rotational workpieces. So for that we use a different type of coordinate system. So let's start with the flat coordinate system first. In this case, as you can see from the diagram as well, our workpiece is in a square shape. It's in a flat shape. So basically, for this type of workpiece, our coordinate system should have six axes. Three are linear axis and three are rotational axis. So as you can see, the three linear axes are X, Y, and Z, and three rotational axes are A, B, and C. So what exactly does the x-axis specify? If we want to move our workpiece towards the left hand side or right hand side, then we have to specify the coordinates in x-axis. If we want to move our workpiece towards the column of our NC machine or away from the column of our NC machine, then we specify those coordinates in the y-axis. Similarly, if we want to move our workpiece towards the spindle, so spindle is basically in which our tool is attached. If we want to move our tool towards the spindle, then we have to give the specification in z axis, that is the positive z. And if we want to move our workpiece away from the tool, then we will give the specification in minus z axis. So basically these are the three linear axes that are used in a CNC machine. Then there are three rotational axes as well, A, B, and C. If we want to rotate our workpiece in x axis, then for that we have to use the A axis. Similarly, if we want to rotate our workpiece in y axis and z axis, then we will be using the B and C rotational axis. One more thing that has to be seen here is that how can we check whether our rotational direction is positive or negative. So for that we use the right hand thumb rule. Suppose we are pointing our thumb in the positive x direction, and if we curl our fingers, then the direction in which our fingers get curled will give you the positive rotational direction. So as you can see, the x-axis here the plus A shows positive rotational direction A. So obviously, if you point your thumb towards the positive x direction, your fingers will be curled inwards. That's why it is positive A. So next coordinate system that we see is for rotational workpieces that we use in a lathe machine. So basically in this type of workpiece, only two axes are sufficient to perform operation on the workpiece. And these two axes are x-axis and z-axis. So what exactly z-axis is used for? The z-axis is used, it is the axis of rotation of the work part. So basically it is the axis along which our workpiece rotates. As you can see, minus z and plus z. And what does x-axis specify? X-axis defines the radial location of the cutting tool. So exactly our tool at any point of time, our tool is at what point with respect to our center line. So for that we use x-axis. So these are basically two types of coordinate systems that are used in an NC, or you can also say CNC system. Then next topic that comes is what is fixed zero and floating zero. So basically fixed zero and floating zero, both these terms are related to basically origin. In one case we are specifying the origin. We are specifying the origin always at the lower left corner of the workpiece. Whereas in the other case, we can define or specify origin at any point on the workpiece. So basically these two terms are related to origin only. So as you can see, the first possibility is for the machine is to have a fixed zero. In this case, the origin is always located at the same position on the machine table. So basically my origin will be always at the lower left corner of the workpiece. Usually that position is the lower left hand corner of the table. Now what is floating zero? The second method allows the machine operator to set the 0 point at any position on the machine table. So basically what exactly floating zero means, that it gives me the flexibility that I can define or specify my origin on any point on the workpiece. So where can we use this method? If my workpiece is symmetrical, then from on that type of workpiece we can use floating zero as well. So this feature is known as floating zero. Next topic that comes is what is absolute and incremental positioning. It is very important topic, whether you are using an NC machine or CNC machine. The programming tool that we use in the programming is G90 and G91. G90 is used for absolute, G91 is used for incremental. So what exactly is absolute or incremental positioning? See, from the diagram, we can also see that in case of absolute positioning, when we move our tool from one point to the second point, my tool will always move with reference or with relation to the origin. Whereas in case of incremental positioning, my tool will move from first point to second point in relation to the previous tool location. Now let's see with the help of example. As you can see, there is a workpiece shown over here. This is our x-axis, this is our y-axis. Our current location, as you can see, is 4, 5. Here x coordinate is 4, y coordinate is 5. Now suppose we want to move our tool from x4 y5 to x6 and y8. So there are two methods by which we can move our tool from first point to second point. If we move our tool with the help of absolute positioning, in that case our tool is already at x4 and y5. If now I want to move my tool to x6 and y8, then I will give the coordinates to the machine as x6 and y8. Why? Because my tool is always moving with reference to the origin. So as you can see here, x6 and y8, this distance is in relation with the origin. So in case of absolute, we will always give the distance in reference to the origin. Now suppose if my tool is moving in the incremental case, I have programmed my machine for incremental positioning. Now in that case, I will not give x6 and y8 because we are already on x4 and y5. What we will do is we will just add the coordinates that needed to be added to move to the next position. So we have already moved on x4. We want to move to x6. So we will just simply add x is equals to 2 and y3. In this way, we will move from x4 y5 to x6 and y8. So as you can see in incremental positioning, what exactly is happening is we are moving to next tool location with reference to the previous tool location. We are not considering the original tool location. So let's see. Absolute positioning means that the tool location are always defined in relation to the 0 point, or you can say the origin. Suppose a hole is to be drilled at a spot that is 8 inches above the x-axis. So here the depth is also mentioned, and 6 inches to the right of the y-axis. Okay. The coordinate location of the hole would be specified as x6 and y8. Okay. So in this case, we have drilled a hole at x6 and y8 with the help of absolute. Now incremental positioning means that the next tool location must be specified with reference to the previous tool location. Now suppose that the previous hole had been drilled at an absolute position of x4 and y5. Now suppose we have already drilled a hole at x4 and y5. Then if we want to drill a hole at x6 and y8 with the help of incremental positioning, then what instructions we have to give? Then the incremental position instructions would be specified as x2 and y3. So basically what happens is in the previous tool location, our locations will get added up and we will move to x6 and y8. So this is all about absolute and incremental positioning. Now next topic that comes is what are the motion control systems that are used in an NC or a CNC machine. So basically what exactly is a motion control system is basically our tool, how our tool moves on the workpiece. So basically there are three types of motion control system used. First is point to point system. It is also known as positioning system. So as you can see from the diagram as well, in this case our tool moves from first point to the second point, and on that particular point we perform certain operation. It could be drilling, reaming, boring, it could be any operation. So in this case my tool will not be in contact with the workpiece all the time. It will come into the contact only at a particular point. That is why it is also known as point to point system. So what is the objective? To move the cutting tool to a predefined location. Obviously, the location has to be defined previously. The speed or path by which the movement is accomplished is not important. So obviously, in this case, as my tool is not in contact with the workpiece all the time, so at which speed or by what path my tool is moving to the desired location is not important for us. Once the tool reaches the desired location, the machining operation is performed at that position. So obviously, if we are performing at particular point only, then only certain operations can be performed. It could be drilling, reaming, boring, like that. NC drill press are a good example of PTP system. That is, drilling is a good example. Drilling of a hole is performed at the location. Since no cutting is performed between the holes, so obviously, as you can see, we are drilling certain holes at certain points. So no operation will be carried out between the two holes. There is no need for controlling the relative motion of the tool and workpiece between the hole location. So since my tool is performing drilling at specific points, there is no need for us to control my tool. There is no need to control my tool position or path because my tool is not in contact with the workpiece. It is the simplest and least expensive control system. Applications are drilling and spot welding. Now, what is spot welding exactly is? There are two types of welding: spot welding and seam welding. In case of spot welding, we weld two plates at certain specific points between them. Then another type of motion control system that is used is a straight cut NC motion system. So as you can see from the diagram as well, in this case our tool moves along only a particular axis. It could be X axis, Y axis, or it could be Z axis. My tool will move only along a single axis. So let's see, it is capable of moving the cutting tool parallel to one of the major axes at a controlled rate suitable for machining. Now, appropriate for performing milling operations to fabricate workpieces of rectangular configuration. So obviously my workpiece should be either rectangular, square, or flat. On a circular workpiece, will not be able to perform this operation. Not possible to combine movement in more than a single axis direction. So what exactly does this line mean? Suppose I have to move my tool at x6 and y8. So if we want to move that tool at that location, then for that my tool should move in two axes simultaneously. But that type of movement will not be possible in a straight cut NC system. With this type of motion, we can move our tool only in a single axis. Therefore, angular cuts on the workpiece will not be possible. So this is a disadvantage of the system. NC machine capable of straight cut movement is also capable of point to point movement. So obviously when my tool can move in a straight axis, so it can also perform drilling, reaming, or any point to point operation. We can also perform point to point operations with the help of this motion control system as well easily. Now, last motion control system that is being used is contouring NC. It is also known as the continuous path NC system. So basically, our modern CNC machines that we do have, almost 99% CNC system do have contouring NC system or continuous path NC system. So as we can see from the diagram as well, in this case, my tools, we can move our tool along straight path. We can also take angular cuts. So basically, my tool can move along any axis, or it can move in multiple axes simultaneously. So this is the most advanced movement. It is the most complex, most flexible, and the most expensive type of machine tool control. Now, why it has been designated as most complex or most expensive? It is most complex because in this case, my tool will be in contact with the workpiece at all point of time. So since my tool will be in contact with the workpiece at all time, I will have to control my tool positions at all time. So that's why it is more complex and more expensive. It is capable of performing both point to point and straight cut operation. It has ability to simultaneously control of more than one axis movement of the machine tool. So obviously, if my tool is able to take angular cuts, we are able to control my tool movement in more than one axis, or you can say in multiple axes as well. The path of the cutter is continuously controlled to generate the desired geometry of the workpiece. So in this case, the cutter path is continuously controlled. That's why they are also known as continuous path NC system. Some of the common applications are milling and turning. So next is, what are the advantages of an NC machine? Advantages of NC or CNC. Firstly, reduce non-productive time. Obviously, since we are using advanced technology, my non-productive time will get reduced. Then reduce manufacturing lead time. What exactly is the manufacturing lead time? the time that we actually use for manufacturing a certain product, it will get reduced. Because we are using machines for manufacturing a product. Then greater manufacturing flexibility, since we have already programmed what we want to achieve in the machine. So if we want to change my design at any point of time, we just need to change our program, and my machine will adapt to it accordingly. So it will have greater manufacturing flexibility. Improve quality control, obviously, since machine is performing the operation, the quality that the final quality that we will get will be much better than rather than when we are using manual labor for producing our product. Reduce inventory. Inventory is the stock that we keep for manufacturing any product. So that will be required, will also be less. Greater accuracy and repeatability. What exactly is the repeatability means? That we are producing a certain product, uh, same size, same specification of product, we are producing a number of products in a lot size. Lower scrap rate, the waste that is being generated will be less, inspection requirement will be less, and less floor space required. Why less floor space required? Because a single machine is, with the help of a single machine, we are able to perform different operation on the workpiece. So like in the earlier setup, we had different machines, different lathe machines, milling machine, and drilling machine. Nowadays there is no need for that. A single CNC machine is capable of performing all the operations on the workpiece. So obviously with the help of this, my floor space will be less reduced. Then what are the disadvantages? Obviously with some advantages, some disadvantages will also come. Firstly is the higher investment cost. Since we are using machinery, we are using higher technology. So at some stage or at initial stage, we will have to invest something. So firstly is the higher investment cost. Secondly is the higher maintenance cost. Since more number of tools will be employed, more number of sensors will be employed in a CNC machine, so their maintenance cost will also be increased. Thirdly, finding and training NC personnel. Then to find appropriate person who can operate my CNC machine without any fault, that itself in a huge task. So that will be also be a disadvantage. And lastly will be the part programming. Earlier when NC machines were not used, then manual labor was used to produce our product. In that case, the programming was not needed at all. But since in a CNC machine we have to feed the program to the machine, so obviously we will have to write a program first before my machine can work on the workpiece. Then what are the applications? Nowadays CNC machines are used in almost all the operations. It could be milling, drilling, boring, turning, grinding. All the operations we can use with the help of CNC machine. Then what are the problems with conventional NC machines? Firstly, it is the part programming mistakes. Now, in when the NC machines came into the existence, earlier on, what we used to do was we used to punch the instructions on the punch tape. But the problem with the punch tape was, if any fault would occur, then we have to then we have to make a new punch tape, because there was no possibility for us that we can modify it. So that was another problem with NC machine. Then no optimal speed and feed. What exactly does this mean is, in the modern CNC machines, when my tool has to change its position, or when my tool has to change its axis, it recognizes it before my tool has to change its position, and my tool speed slows down. And when my tool changes its direction or changes its axis, my tool automatically gains its original speed. Whereas in case of NC machine, this was not possible. So the second problem is no optimal speed and feed. Then the punch tape. Obviously, the punch tape that earlier on that was used in an NC machine was made of paper. So we cannot use it multiple times. It deteriorated over a period of time. So there was a possibility that we can use it only a certain number of times only. Then over a period of time, we developed more durable materials such as mylar, but it was more expensive to make a punch tape out of that material. Then another disadvantage is tape reader. Now, tape reader is the most unreliable component of the NC machine. Now, whenever any fault used to occur in an NC machine, the repair maintenance personnel, the first thing that he used to check was tape reader, because it was the most unreliable component of the NC machine. Then the another disadvantage was the controller. as it was just a hard controller. We did not have any possibility of adding or modifying it. Now next comes what are the features of a CNC machine. So firstly, storage of more than one part program. Obviously, with the CNC machines comes the storage facility as well. So we can store multiple programs in the memory. Then various forms of program input. Earlier on, in case of NC machines, the input we there was input medium was only one with the help of punch tape. Whereas in case of CNC machines, there are multiple ways of program input with the help of floppy drive, CD drive. We can download the programs from the internet. So there are various forms of program input. Then program editing at the machine tool. Obviously, since my program is already residing in the memory, if I want to change my program at any point of time, I can edit it manually as well with the help of with the help of CNC machine control unit. There is no need for me to change the entire program. I can change it at any point of time. Then acceleration and de-acceleration calculation. So as I had already told you, in case of CNC machines, my tool has the flexibility of increasing and decreasing its speed. As soon as it recognizes that my tool will change its axis, moving on, my tool automatically increases and decreases its speed. Then diagnostic. CNC machines comes with a diagnostic capability, that is, it can automatically detect any malfunction that is occurring in the machine, and then it can detect and will tell the operator. Then next topic is machine control unit for a CNC machine. So basically there are five components of a machine control unit of a CNC machine. Firstly is the memory. In memory there comes the two types of memory, RAM and ROM, read-only memory and random access memory. Then the CPU. Then thirdly is the input-output interface. Then machine tool control and sequence control. So we will see each of these components in detail in the upcoming slides. Firstly is the central processing unit or the CPU. So it is the brain of the MCU. It manages other components in the MCU based on the software contained in the main memory. So we can divide CPU as well further. It can be divided into three sections. Firstly is the control section. It retrieves commands and data from the memory and generates signal to activate other components in the MCU. So basically what its function is, it will retrieve the command and data what we have stored in the memory, and it will generate the corresponding signal for the tool so that it can work on the workpiece. Then second thing is the arithmetical logical unit. It consists of circuit to perform various calculations such as addition, subtraction, multiplication, counting, and logical functions required. So obviously as my tool is moving from a certain point to another point, a number of calculations has to be done. So that that calculation is performed by arithmetical logical unit that is contained within the CPU. Then comes the immediate access memory. It provides a temporary storage for the data that is being processed by the CPU. Second component of the MCU is memory. It is required for various program and data needed to operate in a CNC machine. Memory can be divided into two categories: main memory and secondary memory. Main memory it is also referred to as primary memory. It consists of ROM and RAM. ROM is read-only memory. RAM is random access memory. Obviously, with read-only memory, we cannot modify it. Whereas in case of random access memory, we have the flexibility of changing it. Part programs are stored in RAM devices. Then comes the secondary memory devices. It is used to store large program and data files which are transferred to the main memory when needed. It includes hard disks that are permanently installed in a CNC control unit. So my hard disk comes under the category of secondary memory. Then comes the input output interface. Obviously, in case of CNC machines, there are a number of input output interface. It could be the control console that we generally use, or it could be the keyboard. So these all comes under the input output interface. It provides communication between the various components of CNC system and machine operator. It transmits and receives data and signals to and fro from the external devices. So what are these external devices basically are? It could be keyboard, it could be console, it could be various things. By the operator control panel, the machine operator communicates to the CNC system. It is used to enter commands related to part program editing, MCU operating mode, speed, feed, cutting fluid, pump, on and off. So basically with the help of operator control panel, it can be used for various operations. It can be used to feed the MCU operating mode, speed, and feed. Keyboard is usually included in the operator control panel. The input output interface also includes a display. Now earlier on, the CNC machines that we used to had, they had a CRT display, but nowadays they are changed with the LED display for communication of data and information from the MCU to machine operator. So what exactly is CRT means? CRT means cathode ray tube. Earlier on, the display that we used to have was based on cathode ray tubes, but nowadays the display that we use is LED. It also includes more than one means of entering part program into the storage. The programs can be entered manually or stored at a central computer site. Fourth thing that machine control unit consists of is controls for the machine tool axis and spindle speed. So what my tool, it is held in the spindle. So how will I change my tool speed? It can be controlled with the help of machine control unit only. So these are the hardware components that control the position and the velocity of each machine axis. We have already seen that there are 6 axes used in case of flat or prismatic parts, 3 linear axis, 3 rotational axis. So how can we control those axes? With the help of machine control unit of a CNC machine. Positioning system can be classified as open loop and closed loop. Spindle is used to drive either the workpiece or a rotating cutter. So obviously spindle can be used either for holding the workpiece or for holding the cutter. Turning exemplifies the first case, whereas milling and drilling exemplifies the second case. So in case of turning operation that we carries out on lathe, the spindle is used for holding the workpiece with the help of chuck, 3-jaw chuck or 4-jaw chuck. Whereas in case of a milling and a drilling machine, the spindle is used for holding the tool. Then fifth is sequence control for other machine tool functions. Now what are these other machine tool functions? In addition to control the table position, feed rate and spindle speed, several additional functions are required to be done that can be controlled as well with the help of machine control unit of a CNC machine. Now next thing that comes is CNC auxiliary functions. What exactly auxiliary functions means? The added functions or the extra functions that a CNC machine has to achieve other than what are the basic functions were. Now what are these auxiliary functions are? Coolant control, on and off output from the MCU to pump. We have to use the coolant so that my tool doesn't get heated up more. Tool changer and tool storage unit, fixture clamping device, emergency warning or stop, robot for part unloading and loading, and counters. So these all operations come under the auxiliary functions. Now, how does CNC machine perform these auxiliary functions? We cannot just put the entire load of a CNC machine on its CPU or on its MCU, machine control unit. So to perform these auxiliary functions, what we do is we generally attach a PLC with a CNC system. PLC is programmable logic controllers. We use PLC with a CNC machine to perform these auxiliary functions. Then the next topic comes is what are the software that we generally use in a CNC machine. Obviously, in any type of machine, we have to have some sort of a software to perform it. So there are three types of software that are being used in a CNC machine. Firstly is an operating system software. Its function is to interpret the NC part program and generate corresponding control signal to drive the machine tool axis. It is installed by the controller manufacturer and is stored in the ROM in MCU. So just like whenever we purchase any computer, the software is already pre-installed in it. Who install it? The manufacturer of the computer. Similarly, just whenever you buy a CNC machine, the operating system software will already be installed in it by its manufacturer. So what are the things comes under the operating system software? Firstly, it consists of an editor which permits the machine operator to input an NC and edit NC part programs. So with the help of editor only, we have the possibility, or we can edit our NC part programs with the help of editor, and editor is stored in the operating system software. Then comes the control program. It decodes the part program instructions, perform acceleration and deacceleration calculations and interpolation. So whatever the program that I am feeding in a CNC machine, who decodes it? It is decoded by the control program that is stored in the operating system software. Then comes the machine interface software. It is used to operate communication link between the CPU and machine tool to accomplish CNC auxiliary functions. So basically, to perform the CNC auxiliary functions, the operating system software that we use is a machine interface software. And lastly is the application software. It consists of NC part programs that are written for machining applications in the plant. So basically, these are the three types of software that are used in a CNC machine. So before moving forward, let's just revise what are the topics that we have done today. So basically, we have seen that there are two types of coordinate systems in a CNC machine. One coordinate system is used for a flat or prismatic work parts. It consists of 6 axes, 3 linear axes, and 3 rotational axes. Another type of coordinate system that is used in a CNC machine is used for rotational workpieces. In this case, we need only 2 axes, x-axis and z-axis. Then we have seen fixed zero and floating zero. Both these terms are related to origin. In one case, my origin is always located at the lower left corner of the workpiece, and in another case, uh, my origin we can locate our origin at any point on the workpiece. So next topic we will discuss in the next class. Okay.